This section, we're going to look at event involving N and event involving conditional probabilities. We did look at event involving OR before, and if you recall that when it's involving OR, you're adding the probabilities. Here, when your event is involving N, then you're going to multiply. So example 1, you are dealt 2 cards from a 52 card deck. Find the probability of getting 2 kings. So when you're getting 2 kings, let's say you're going to have first time picking king and then second time picking king. First time picking king, you have 4 king cards from 52. And then because you pick 1 in the first time, now you have only 3 king remains out of 51 card. And this have to happen at the same time. So you're going to multiply this. And multiplication, you should be able to reduce before you multiply to make it easier, multiplication. Or if you have a calculator, you can just input this number into the calculator. But let's say if we do not have and we wanted to reduce it, 4 goes into 52 13 times, 3 goes into 51 17 times, which will give you 1 over 13 times 1 over 17. And when you multiply that, that will be 1 over 221, which is close to 0.0045 as the probability of that case. Example 2. If the probability of South Florida will be hit by a hurricane in any single year is 5 over 19. What is the probability that the South Florida will be hit by a hurricane in 3 consecutive years? So consecutive means one after the other ones. So if it's 2020, then 2021 and 2022. So 3 years straight. The first year is going to be 5 over 19. Second year will be also 5 over 19. Third year, 5 over 19. And this have to happen straight all together. So we're multiplying, right? We are multiplying this. And when we do that, this is going to be same as 5 over 19 to cube. And if you use your calculator, you get 125 over 6,859 in a decimal form of 0.018 probabilities. What about B? What is the probability that the South Florida will be hit by a hurricane in the next 10 years? So this, what we're looking for is probability of at least one time, right? One time in next 10 years. And if you think about it, this is going to be a pretty large number, this pretty large probability, because each year you're going to have 5 over 19, right? And if it don't happen that year, the next year, the probability will get bigger, right? So this is going to be pretty large probability. So what I like to do is subtract this from your event involving not sections, right? So it will be 1 minus probability of no hurricane in 10 years. So then the probability of no hurricanes, because the hurricane is going to be happening in each year 5/19 probabilities, right? So the other not going to happen is going to be 14/19. And for 10 years, you're going to multiply that 10 times. And when we get that value, it's close to 0.047. And then when you subtract 1 from that number, then you get 0.953 probabilities. And as you can see, it's pretty large. If you convert this into the percent, it's going to be over 95%. One more problem involving n. Example 3. You're dealt 3 cards from 52 cards. Find the probability of getting 3 hearts. So we know how many hearts we have. Remember, each shape have 13 cards. So hearts, we have 13 cards. So we will have 13 out of 52 to start it. And we're picking 3 cards. So this is what happened when I picking card for the first time. For the second time, I only have 12 hearts remains out of 51. And then third time that I can pick heart is going to be now 11/50. And when you're multiplying all this, you're going to get multiply and reduce, I guess. Or if you multiply all this, change to decimal, it's going to be 0.0129. Like I said, multiply and reduce, it will be 11/850, right? And that's going to be your probabilities. Now we're going to look at the conditional probabilities. So when we're dealing with the conditional probability, they like to use the word given that, right? So let's look at example 4. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome is the letter that precedes H. So I like to write this as the conditional probability first. So we're looking for a probability of picking vowels. Given that, so we use the absolute sign, but just the one dash going up and down, right? Given that, letter precedes H. And we need to know what's the given that, right? So what's the outcome of the letter before H? So the sample space of that is going to be A, B, C, D, E, F, G, and before H, so that's going to be it. So from this, finding a vowel, right? So how many sample space we have? We have 7. So this is going to be total of 7. How many vowels you have here? A and E, so it will be 2. So picking A or E, right? So when they're talking about conditional probability, your total size is going to become your conditional outcome. Okay. Let's look at one more. You are dealt 1 card from 52 cards. Find the probability of getting a heart. So again, we're looking for a probability of getting a heart. Given that is a red card. So red cards, you have half of them are red and half of them are black, which is going to be 26 out of 52. And how many hearts there? 13. And when you reduce this, this is 1/2. And that will be your probability of getting a heart given red card. What about the next one? Find the probability of getting a red card, right? So this time, getting a red. Given a heart, right? Given a heart. And how many hearts? There is 13. In that 13, how many red there? 13. So all the hearts are red. So your probability is going to be 1. If you convert that to the percent, it will be 100%. So if the red card was given, your chance of or probability of getting a red card will be 100%, which is 1 probability. Example 6, we have a chart given here. This is about salary the president of college or university earn per year. So we have university and community college, and this is how much they make. Earn less than this amount, and earn 250,000 or more is this amount. And this is the total of the university president, and this is community college president, right? And they want you to let A be the earn 250,000 or more, so this is going to be A. And B be the community college president, so we're going to let community college president will be B. An example A, find probability of A. So probability of earn 250,000 or more, and probability of not A. So that's going to be earn less than 250, right? So let's look at probability of earn A. That's going to be, we're going to look at the total because they didn't mention anything about is it going to be university president or community college president. So we're going to use the total of 115 all over here. 189, right? 189, which is giving 0.608. And then if we wanted to find not A, that's going to be this, right? This is A, this is not A, and that's going to be total. So then this is going to be 74 over 189, which is 0.392. So that's the probability of A and A naught. Then what about, we're looking at the conditional probability. So find probability of B given A, right? So find the probability of B, community college president, given A, right? This is given. So then we're going to find intersection of A and B and number of A, because number of A was what? The total as the conditional probabilities, right? So that's going to be 115. number of A is 115, and number of A and B, that's going to be 14. So number of A intersect B, right? So that's 14. And it gives you 0.122 as the decimal point. What about finding probability of B naught given A naught? So B naught is going to be university president, right? University president is B naught. And A naught is going to be earned less than 250. So if we wanted to find out number of B naught intersect A naught on the numerator value, and denominator will be number of A naught. So number of A naught is going to be 74, right? A naught 74. And then number of B naught intersect A naught is going to be 53. You will get 0.716 decimal. So last example of this section, we have probability of E given, probability of F given, and probability of E union F given. And they're asking you to find the probability of E given F. So what we know about probability of E given F, we use the formula from example 6 also, that we know this is equals to number of E intersection of F over number of F. And we also know that probability of E union F is equals to probability of E plus probability of F minus probability of E intersect F. So if we replace all these values, so what was given? E union F was 0.7 as the given. Probability of E is 0.4 given. Probability F is 0.5 as given. Then we should be able to find probability of E intersection of F. Then we should be able to replace that into here and then find the E given F, right? So then let's see. This is going to be, let's say, unknown. Then we have 0.7 equal 0.4 plus 0.5 minus x. When you move minus x to other side, it will become plus x. And 0.4 plus 0.5 is 0.9. And then in order to isolate x, you're going to subtract 0.7 from both sides of equations, where I will get x value is going to be 0.2. So that x is probability of E intersection of F, which is 0.2. Then now we can use that value to plug in. So it will be 0.2 over probability of F is given, which is point F, right? That's going to be probability of E given F, which is going to be 0.4.